Okay, this is the corrections for complex numbers, solving quadratic equations, solving nonlinear systems, and polynomial operations test corrections. This will be focusing on Unit 9, which is solving quadratic equations and simplifying radicals. And so we're going to start there at question 1. And question 1 says you need to simplify this and write it in simplest radical form. So it was 2 root 14 times 7 root 21. Okay, so that's what it was there. And what I would do is right away regroup it. So it's 2 times 7 times root 14 times root 21. This is root 7 times root 2. Both are prime, so I'm done simplifying that. There's no perfect squares. Root 7 and root 2. Turns out that you have a square root of 7 and a square root of 7. That's a square root of 49, which is a normal 7. So when I rewrite this, this is 14, that's these two here multiplied, times 7, that's this one right here. And then I'm left with a square root of 2, this is actually a square root of 3, I just noticed that, times a square root of 3. Square root of 2 times a square root of 3. That's 98. That's root 6. So in simplest radical form, you have to get out all the perfect squares from under there and make them normal numbers. In that case, we had to find the pair of 7s here under the square root. That would give you square root of 49, which is root 7. Okay, I'm going to go to the next problem, which is number 2. Okay, number 2 is... Okay, another thing with simplifying radicals is you can't leave a square root on the bottom of a fraction. It must go to the top. Now, if you multiply by root 5 to top and bottom here, you'll get rid of this root 5, but you'll insert one right here, which will defeat the purpose of what you're doing. So we have to use a conjugate. So it looks the same, 2 minus root 5, and that will give you, when you do that, and you multiply the bottom by that, that will give you 2 squared, and that will give you, that will give you also 2, so that's 2 squared. That will give you 2 root 5. That will give you root 5 times a root 5, which is 25, which is 5. Okay, and then you'll get root 5 times root 2. It's a negative though. I totally messed that up. Let's go back here. I totally messed that up, so I'm sorry. So when you do that, you can FOIL, that's 2 squared. Then you can go 2 times negative root 5. It's negative 2 root 5. And then you can go root 5 times 2, so that's plus 2 root 5. And you can go root 5 times root 5, which is a normal 5. It's a square root of 25. But again, once again I made a mistake here because this is a negative here. Whoops. This is a negative here. So this is actually negative 5 in front. Let's make that look like the other ones. So I do all that. The bottom of the fraction simplifies to, well, it's nice because this cancels out that. And so you get 4 minus 5, which means we're over negative 1. Now you notice I just worked the bottom there. And if I had just stopped here, I've actually made a mistake because I can't just arbitrarily multiply by a number on the bottom. I need to multiply by a fancy version of 1. So I'm going to actually multiply by the same thing on top. So I'm actually just multiplying by 1. And when you multiply by 1, it doesn't change your answer. So now I'm going to have to 3 times 2 and 3 times negative root 5. 3 times 2 is 6. 3 times negative root 5 is negative 3 root 5. So it's 6 minus 3 root 5. 6 minus 3 root 5. And if you don't want to leave the negative on the bottom, you can distribute it to both of those. And so you get negative 6 plus 3 root 5. And there's your answer right there. I'm going to go to number 3 right now. Okay, so a lot of you, when you did this, you wanted to multiply the top and bottom by root 125. And you're welcome to do that. But you're going to create a lot more problem with simplifying. So what I'm going to do first is remember that I can write this as the square root of 36 over the square root of 125. And let's think about what 125 is. 125, if you do your factors, is root 5 times root 25. This happens to be 5. So we can write this on the bottom as 5 root 5. The square root of 36 is 6, and a lot of you stopped here. Unfortunately, you have a square root in the bottom. That is not simplified radical form, but it's not like the previous problem where you need to multiply by a conjugate. We can just multiply by a different version of 1. Root 5 times root 5 is 5. So when I do that, there's my fancy 1. It's going to give me 6 root 5. These two together give me a normal 5, and then I still have the 5 in front, and I have a normal root 5 for those two. I mean a normal 5. So my answer is 6 root 5 over 25, and that's the simplified answer right there. Okay? Okay, this is number 10. The next, so I've done 1, 2, and 3 already. And we're supposed to solve this equation by factoring. Okay, it says by factoring. Some of you tried to complete the square, or you did the quadratic formula, and that's fine normally, except it gave you specific instructions. You had to factor it. And I think I forgot to write the x here on the 12. So there's an x there. So I need to find a GCF, a greatest common factor. Well, 3 goes into 12, and there's an x in each term. So I'm going to go 3x out, and I'm going to be left with x plus 4 equals 0. And if you really think about it, I've got two factors. 3 times x can equal 0, or x plus 4 can equal 0. Subtract 4 from both sides, divide by 3 to both sides on that one, and you get x equals 0, x equals negative 4, and you are done the problem. It's that simple. Let's go to number 11. It's again, solve by factoring. So I have 2x squared equals 4x plus 96. Well, I don't want to have negative x squared, so I'm going to bring the 4x and the 96 over. So minus 4x minus 4x. And don't worry, it's not going to go with the 2x squared. And minus 96. So I'm going to get 2x squared minus 4x minus 96 equals 0. Well, it'd be really convenient if we just divided everything or multiplied everything by 1/2. Okay? So when you do that, I can multiply by half or divide by 2 to everything. I'm going to get x squared minus 2x, and that would be 48. So now I need to ask myself, what are the factors of 48 that subtract to 2? Well, it turns out it looks like 8 and 6 are the lucky factors. Okay, so 8 and 6 are the lucky factors. And so I get x, and I need more negatives. It's because it's a negative 2. So then I set x minus 8 equal to 0, x plus 6 equal to, or x plus 6 equal to 0, and I can get an x as negative 6, or I can get an x equals 8. Okay, as simple as that. Okay, here's number 12, and it says, again, Solve the quadratic equation by factoring. So I'm going to have to subtract 21 from both sides. I get 2x squared minus 11x minus 21 equals 0. So one way to do this is to find the factors of 2 times 21. So, whoops, I'll go back here. Of 2 times 21, and I want them to subtract. So 2 times 21 is, well, wrong color. Factors of 42 is 1 and 42. Well, those don't subtract to 11. 2 and 21. Those don't subtract to 11. And I've got 3 and 14. Well, 3 minus 14 is negative 11, and 14 minus 3 is 11. So this is the pair I want. And I'm going to do it by grouping. I'm going to just put 3x and 14x. Then I'm going to bring down the minus 21 and the 2x squared. And I have to get the signs. Okay? Well, I want more negatives, so the bigger one gets it there. Now I'm going to have to do my grouping here. So I'm going to just make that a group, and make that a group, and look for GCF in each group. So I get here, well, I only got an x in each of those. So I'm going to get x, I'm going to get 2x plus 3. Here I'm going to get a negative sign, and I'm going to take out a 7. So that's going to be 2x plus 3 as well. Well, it turns out I've done it right. Those are the same. So it's 2x plus 3 can come out, and I'm left with an x minus 7. So now I'm going to let 2x plus 3 equal 0, or x minus 7 equals 0. So x can equal 7. And if I subtract 3 and divide by 2, I'm going to get x equals negative 3 divided by 2. Those are my two solutions to it, if you let y equal 0. Okay, I think I'm going to stop this. I'll do a second part, and I'll upload this right now. So there'll be a second part, and that will pick up on, that was number 12, so I'll pick up on number 13 in the next video.